Hello friends, Aditya Bhavani here. Today we are going to learn the numericals on Pelton wheel. At the end of this session, student will able to solve the numericals on Pelton wheel or turbine. Let us study first example. So Pelton wheel having a mean bucket diameter of 1.2 meter is running at 1000 rpm. The net head on the Pelton wheel is 840 meter. If the side clearance angle is 15 degree and the discharge through the nozzle is 1.12 meter cube per second. Determine power available at the nozzle and hydraulic efficiency of the turbine. So let us understand what the statement is and what we need to find out. So basically they have given the mean bucket diameter, that is capital D, as 1.2 meter and speed is given as 1000 rpm. Then Pelton wheel net head, that is capital H, net head is given as 840 meter. Side clearance angle, that is phi, is given as 15 degree. And discharge through the nozzle, that is Q, is given as 0.12 meter cube per second. So what we need to find out? Power available at the inlet of nozzle. What we know, power available at the inlet is nothing but water power. That can be found out from the equation rho g q h. And hydraulic efficiency of the turbine, for that we have formula. This 2 in bracket v minus u in bracket 1 plus k cos phi by v1 square. So this is what Pelton turbine velocity triangle at inlet and outlet. At inlet it is straight line and at outlet it will be like this one. So in this case you need to remember that the blade velocity at inlet and outlets are remained same, that is u1 equal to u2 equal to u, and in this case there is no mention of clearance or friction between the blade and blade surface and water. So which means I can take relative velocity at inlet and outlet will be same, or blade friction coefficient can be taken as 1. Now in this case we have diameter equal to 1.2 meter, speed of the wheel equal to 1000 rpm. So we can find out u, that is blade velocity, u equal to pi dn by 60. In this case diameter is 1.2, speed is 1000. So if you substitute the value in this equation, you will get 62.83 meter per second. Height is 840 meter. Side clearance angle phi equal to 15 degree. Discharge equal to 0.12 meter cube per second. Now power available at the nozzle, which is nothing but water power. Water power can be calculated as rho g qh. So power available equal to rho g qh. So rho is 1000 into g is 9.81. So 1000 into 9.81, that is 9810 into q, discharge is given as 0.12 into head, that is 840. So you will get as 98848 Newton meter per second or joule per second or watt, or I can say 988.85 kilowatt. So now we have the formula for hydraulic efficiency as 2 in bracket v minus u in bracket 1 plus k cos phi into u by v1 square. So this we know from last derivation. So for that we need to know v1. So v1 can be calculated as v1 equal to cv into under root of 2gh. If cv is not given, take cv equal to 1. So I can say 1 into 2, 9.81 into 840. So I get 128.38 meter per second. So hydraulic efficiency equal to 2 instead of v1, 128.38. u we have calculated as 62.83 in bracket 1 plus k cos phi, that is cos of 15 into u divided by v1 square. So you will get 98.2%. Let us understand next numerical. A Pelton wheel is to be designed for following specification. In this case, some specifications are being given and we need to find out its dimensions. So power or shaft power is given as 9560 kilowatt. Head is given as 350 meter. speed 750 rpm, overall efficiency is 85%, and in this case jet diameter is not to exceed 1/60 of the wheel diameter. So what it means, jet diameter, small diameter, which should not be exceed to that of wheel diameter, that is larger diameter by 1/6. So small d by capital D equal to 1/6. And what we need to find out, the wheel diameter and diameter of jet and number of jet required. So let us understand. We have shaft power 9560 kilowatt, head as given as 350, speed we have this ratio, also we have small d by capital D, jet ratio, and they mentioned the coefficient of velocity and speed ratio as 0.985 and 0.45 respectively. Now to find out diameter, we know capital diameter, that is wheel diameter, can be calculated as u equal to pi dn by 60. So for that case we need to find out blade velocities, that is u. So how u will be calculated? We know u equal to ku into under root of 2gh. Okay, so we have cv and ku, so we can find out v1 and u. So v1 equal to cv into under root of 2gh. So what I get, 0.985 into under root of 2 into 9.81 into 350, I get 81.62 meter per second. Blade velocity will remain same for Pelton turbine, so u equal to ku into under root of 2gh. If we substitute the value, you will get 37.3 meter per second. Now in this case u equal to pi dn by 60, this formula we know. Substitute the value of u, 37.3, pi dn is given as 750 rpm divided by 60. So lastly you get d equal to 0.95 meter. Now in this case jet diameter d by d, that ratio is given as 1/6. So d equal to d by 6. So 0.95 that we calculated divided by 6 equal to 0.158 meter. Next is the number of discharge jet required. So in this case discharge of through one jet will be area into velocity, that is q equal to area into velocity. So area in this case, area of jet, so jet is mentioned, so pi by 4 into d square into v1. Through single jet, pi by 4 into 0.158, this is 158 small diameter. Many student makes mistake here, so we need to take 0.15 small diameter into 81.62, which will be equal to 1.6 meter cube per second. Next is overall efficiency, that we know shaft power by water power. That is overall efficiency is what exactly what we get at the end divided by what is input energy. So input energy is water power, that is rho g qh. So rho g into qh. So shaft power is given 9560. So both are in kilonewton. So I can, here I am taking rho g as 9.81 kilonewton. If I am taking this as 9.81 into 1000, so I need to consider here 9560 into 10 raised to 3, that is in watt. So if I substitute this value, efficiency is given as 85%. So what I get, q equal to 3.27 meter cube per second. So this is total discharge. It is for overall efficiency. We are calculating for overall efficiency. So now number of jets required will be equal to q, that is this total discharge divided by discharge through one jet or single jet. So you will get the number of jet required for this particular application. Next is assignment. Let us understand what is given and what we need to find out. A Pelton wheel running at 480 rpm and operating under an available head of 420 meter is required to develop a 4800 kilowatt. So in this case rpm is given, available head is 420 meter, and power is given, it is shaft power. There are two equal jets, so there are two equal jets, and the bucket deflection angle is 165 degree. So angle of deflection is 165 degree, so phi angle will be 180 minus 165. The overall efficiency is 85%. Again overall efficiency is given. When the water is discharged from the wheel, in the direction parallel to the axis of rotation. The coefficient of velocity of nozzle, that is Cv, is given as 0.97, and the blade speed ratio, that is Ku, is given as 0.46, and the relative velocity of water at exit from the bucket is 0.86 times the relative velocity of at inlet. So what it means, relative velocity at exit, that is Vr2, will be equal to 0.86 times Vr1, and we need to find out cross sectional area of each jet, then bucket pitch, circle diameter, and hydraulic efficiency of turbine. Now in this case we are given speed, height, then power, then angle, then hydraulic overall efficiency, then coefficient of nozzle, velocity, and speed ratio. So from this we can find out the discharge. Since overall efficiency is given, overall efficiency equal to shaft power by water power, that is rho g QH. So in this case rho g Q we need to find out, H is given, so it is from that you will get H, Q you will get, that Q will be overall Q. Now from overall Q you can find out the area, that is Q equal to area into velocity. So if you get area, that we need to find out, first thing, cross sectional area of each jet. Second thing, bucket pitch circle diameter. Now in case of bucket pitch circle diameter, you can find out capital D as U equal to pi dn by 60. So for that case you need to find out U equal to Ku into under root of 2gh. From that equation you can calculate U, and then subsequently substitute that U value in U equal to pi dn by 60, you will get diameter. And lastly, hydraulic efficiency of turbine. For that case we have formula as hydraulic efficiency equal to 2 in bracket V minus U in another bracket 1 plus K cos phi into U divided by V1 square. So from that calculation you will get the hydraulic efficiency. So you can easily solve the numericals on Pelton turbine. This will be the conclusion. Thank you.